Hello. Um, Dominique, unfortunately, last moment couldn't come. So on behalf of her, I'm going to present this paper today. That's okay?
It's okay.
Yeah? Okay, perfect. So should I start my screen right now?
You can share your screen.
Okay, thank you. Perfect. In that case, I'll start right now. So first of all, thank you for giving me this opportunity. Today and good afternoon, I think it's afternoon there. First of all, our paper is called the second order adaptive neural network model of dreaming and creativity, which I'll present today. And before I will introduce my topic based on an example, because you probably know the benzene structure thought by or made by Kekulé. He allegedly dreamt about this structure in a cabin. This dream can be considered a creative dream. Previous reports have also shown us that these types of creative dreams, so dreaming about something and then using that content to solve a problem, occur about 8% of the time, which is actually quite big. And even though the prevalence is relatively high, there is actually not that much research about this topic or phenomenon. So this is why we took it upon us to try and create a model about it. That was the introduction. Next, I'm going to talk about mechanisms, our model that we designed, simulations, analysis I do not have in here, and the discussion. So first of all, we define dreaming as a series of activated mental images as internal or mental simulation with hyper-associative characteristics, such as you have different types of contents sparsed in your head that are non-obviously connected to each other, but this hyper-associative characteristic means that it could be connected to each other, even though it does not seem plausible. For example, relating an ape to iron. This can be seen as creative or associative thinking. Creativity is defined as the ability to combine associative elements, which means to create a new combination using previous experiences. So also a sense of associative thinking. We found in our literature that there are similar brain and cognitive processes. The ones that we included in our model are that there's an increased striatal dopamine concentration, which facilitates cognitive flexibility and cognitive exploration, which is defined as associative thinking. And this concentration is actually increased in striatum during dreaming. Furthermore, the inhibition of frontal regions, in this case, we took the BFC, during wakefulness are actually preventing or repressing this associative thinking from happening during wake, but are less active, so allows for hypersociative thinking during dreaming. And as well, strengthening of learning happens through prior experiences. Yes, so with this basis, I will bring you through our modeling approach, which is a self-modeling approach made by Jan Thur, which models complex dynamic and adaptive processes, including single causal impacts, aggregation of multiple impacts, and also modeling the timing of these impacts to happen. So next, on the left or on my right, I have descriptive. I have my descriptive model, and the pink planes are the base layer, which is just a singular situation effects has, or an effect is happening, not really adaptive or dependent on anything else. The second layer, or the first layer of adaptivity, however, models this learning of types of connections that we make. It basically helps us sort of like based on Hebbian learning principle, neurons that fire together wire together, you're likelier to remember these types of, let's say, dreams if you learn them, right? And the second order is the speed of learning, which is modeling metaplasticity, which controls whether learning will happen or not. And now I'll show you in an illustrative manner how our model looks. So this is our base plane. And as you can see already, there is a repetitive structure in the middle. These structures that are repeated are basically dream stages. As we know, our dreams consist of stages or a representation of something that's happening. I want to illustrate that these two PBs mean problem stages. So there's a problem in the wake that someone has, and during a dream, we'll get to some type of solution. Let's say that. So the first, I'll explain how this system works, because it is essentially a mental simulation of our dream. And you can see that there's a choice being made here. This is a mental simulation or mental image of our dream, which leads to a choice process. And reality is probably much, much more chaotic than this. For clarity, we made it more simple. We have, for example, we have a choice between eating ice cream or riding a horse. We assumed in our model that based on personal biases, we automatically choose one over the other. Therefore, in this model, we chose the images, or let's say states right now, to model the simulation. So what happens over here is that, okay, we chose this stage. For example, we choose to eat ice cream. There is a bidirectional arrow between these two choices because it's a winner takes all principle. Once eating ice cream, the idea of eating ice cream is more attractive. It activates more, therefore will probably simulate that mental image in our dream stage. Yes, so in this case, the result of this is eating ice cream. And that process continues on the multiple stages of our dreams. As you can see in the front here, this is the prefrontal cortex, or the frontal regions of our brain that we assumed, based on the literature, that kind of represses, represses the dream stages to allow for hypersociative thinking or an increased chance thereof. The WS state means wake state, and the DA is the dopamine, and the SS is sleep stage. As you can see here, when we're asleep, it represses has a repressed effect on the frontal regions, but it has an increasing effect on dopamine, which I'll show in the next part, which is the first. I can press next. Yes, the next part is the first order of adaptivity. It's not very well shown here, but there's an arrow going from dopamine to the TPS, which is an adaptation of the thresholds of the preparation states that you saw before. Also, these preparation states means the preparation for this imagery of eating ice cream, for example. This lowers the activation states, which means if there's a lower activation threshold, it means that there's a higher chance of this state, or that BS state of eating ice cream increases, therefore you'll imagine that dream. And that's further repressed by the dopamine, and therefore it decreases all of these chosen states. The next one is based on Hebbian learning principle, the W states, which basically include learning, as well as remembering or retention of that learning of these states that we chose, one of which is the eating ice cream, once again. The last layer we have is the second order adaptation. We found in literature that actual dream recall is very much associated with remembering your dream. So this MW state means the retention of, or remembering those dream stages that we talked about before, which relate to all the chosen stages we had. And the HW stages, again, represent whether there will be learning. So if they were not here, there probably wouldn't be any learning at all. This is the entire model, and as you can see, as I described before, there is a connection from the minuses over here, but this minus should be there from the dopamine to the thresholds or adaptation thresholds, which then lower all these chosen preparation states for the dream stages. Okay, so the first simulation that we did was with dream recall. To illustrate our model, I basically have these problem states. This is all during wake, all between here. And this is the sleep state. So a person occurs one problem, dreams at some point, and at another point in time, let's say 24 hours later, that they reoccur or the problem reoccurs. So they will have to think about the problem again. This shows the biological underpinnings that I spoke about before, which is the increase of dopamine in the striatum. As you can see here, the lowering of the thresholds of the preparation states that I spoke about, and the repression or decrease of frontal, let's say, repression on the preparation states again. Here we can see within the dream state, what happens is the activation of the mental simulations of these dream stages, one of which, again, eating ice cream. Underneath here, you see activation of the choices that weren't made. But it's important to show this because it shows that these choices were considered by us in our sleep. But the others were chosen as well, as you can see by the high activity. Most important here, these are the W states, which then you can see they continue being very active or remembered, even during wake. Also when the second problem is reoccurring. And most importantly, we also modeled as an outcome the solution. Let's say there is a solution in our dream that we had before, which is over here. We will forget about it during the day because we don't necessarily think about our dream, but once the problem reoccurs, we will again think about our dream, and because the connections were so strong, we remember again, oh yes, this was the solution to my problem. Next part was without dream recall, and you can see it's already quite different. Most importantly are these W states, which show they weren't as active as we saw before. And even when the problem is being recalled again, we just don't remember it that well. But important to see is that during the dream, we did come to a conclusion. So we did have a creative dream, let's say, but because we don't remember it and don't recall it, we also don't come to the conclusion again, even if we're confronted again with that problem, because again, we do not remember it. And then next, conclusion discussion. We think this is one of the first models that try to demystify this phenomenon, and specifically creative problem solving. We did show with our model how it could be possible that this phenomenon occurs. Of course, there could be improvements to this model, and there are some limitations. First of all, this study was based on theory. It would be nice if there was some more data, experimental data on it. As well as I said before, the dream sequence is just not very realistic. It's made for simplicity because normally it would probably be a big expansion of choices that you can make in your dream, or how we can model that. Subsequently, there is possibly, most likely, other biological underpinnings of dreaming and creativity. And I specifically want to note that we use the BFC as an assumption or as a ground region in this paper, but there's a high possibility, or it's possible that that's a more specific reason or region that is inherent to this phenomenon. And also approach-related traits, such as how open am I even to use this dream to solve my problem, for example. But overall, we think this is a good foundation to demystifying this phenomenon that may have led Kekulé to thinking about the benzene structure, as well as how we might think about solutions in our dreams. So that was our paper. Thank you for listening to your question. Oh, I do not hear.
Thank you for the presentation. We will now proceed with questions from the audience. If anyone has a question, please raise your hand.
Yes.
I have a question about it's quite promising modeling. About your last comments about regarding the improvements, I was thinking in this realistic. There is a series of experiments using imaging, neuroimaging during waking. The people waking. It's from California, University of California. And then they register in magnetic resonance the imaging that possibly has to do with the imaging they just saw, they were presented. And that kind of phenomena, I think that would be very interesting to fit your model. And the other stuff that I was thinking is when you said about this more realistic neuroscience data from neuromodulatory incomes, inputs, outputs would only add to the possibility. But I was thinking that not just the possible decisions, but the using of data from images, representation of images could be very interesting for your work.
Thank you. There's a way for you to send me some that would be also nice, and I can look it up definitely. Thank you for your comment.
Any other questions?
I also have a question.
Yes.
Do you think that with this model that you're used, it is possible to represent a dream where different things happen at the same time? Because it seems that you're always putting things in sequences, but I was wondering if you could represent something that are happening at the same time.
Yes, because our dreams are kind of in shambles usually. I think there could be a possibility. I wouldn't know how to answer it specifically right now, but there are modeling techniques for that to happen at the same time, for multiple outputs to happen in, for example, one stage of dreaming. So I think my answer is yes, it is possible. But how? I could not answer right now.
Okay, thank you.
Well, it seems the time for questions is over. So if anyone in the audience have further questions, they can get in touch with the author directly.